Hello, in this video we're going to look at an example of using the binomial distribution, and then we're going to look at how you could handle this with CAS. So this is a calculator free question from the textbook, and we have Marco who has a faulty alarm clock, and the probability that it sounds in the morning is 1 on 3. So we can see already that it's binomial because there's this win-lose situation. And I have to clarify from the earlier video, I said that Bernoulli trials every tree diagram possible. That's not quite right. It's every tree diagram possible when it's a win-lose situation. So we have a probability of success. It's 1 on 3. Probability that his alarm clock sounds. And we also have a number of trials. So we're going to trial this over 4 mornings. So the first thing we can do is define x, a discrete random variable, to be binomial. You can write b or bi, up to you, where we have 4 trials and the probability of success is 1/3. So we're going to try this over 4 mornings, and the first part A, says, well, what's the probability over the next 4 mornings that it works at least 3 times? Well, so that means we're looking at the probability that our discrete random variable is between 3 and 4. That's what we're looking at, aren't we? We're saying, what's the probability that works 3 times or 4 times? So another way to write that would be the probability that x equals 3 or the probability that x equals 4, which is exactly what we're going to write here. So that is equal to the probability that it works 3 times plus the probability that it works 4 times. Well, x is binomial. We're all sweet. We can use that beautiful formula from the last video, and that formula here will be 4 choose 3 times the probability of success to the power of 3 times the probability of failure. I'm doing a shortcut here. 1 minus the third is 2/3. Probability of failure to the power of 1 plus 4 choose 4 times the probability of success to the power of 4 times the probability of failure to the power of 0. So it wants us to do this without a CAS. Well, we need Pascal's triangle. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And here's for 0, 1, 2, 3, 4. So this is for 4 choose something. So that's 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3 is 4, which is what we expect, because there's an identity that tells us that. So 4 choose 3 times 1 on 27 times 2/3 plus 4 choose 4, which is 1, times 1 on 81 times 1. So we've got 8 on 81 plus 1 on 81, which is 9 on 81, which is 1/9. There we are. It's 1/9. That's the probability that it works at least 3 times. What's the probability that it works fewer than 2 times? So in this case, we're looking at the probability that x is less than 2. Well, that's the probability that it works 0 times plus the probability that it works 1 time. So the probability that it works 0 times is 4 choose 0, 1/3 to the power of 0, 2/3 to the power of 4, and the probability it works once is 4 choose 1, 1/3 to the power of 1, 2/3 to the power of 3. So what have we got? We've got 16, 3 to the power of 4 is 81, plus 4 times a third times 8 on 27, which is 16 on 81, plus 32 on 81, which is 38 on 81. Can we simplify that? I don't think we can. There's our answer. Does that make sense? Works fewer than 2 times? Yeah, because it's more likely it doesn't work. So expect that it's more likely that it works fewer than 2 times. Alright, well, I told you that we'd be able to check these with CAS. So let's get out the CAS. Now, you can see a previous example of where I've done it. What you can do is use the function binomial cumulative distribution function. And I'll write the syntax first for it. So what you do is you write binomial CDF. The first argument is the number of trials, the second argument is probability of success. The third and fourth arguments are the range. So the range here is from 3 to 4. So if we write all this information, we should get 1/9. So you go menu, and we pop down to, oh no, I'm gonna have to reload it. Let's wait patiently. So we go calculate, we go menu, and we go to probability, distributions, and we want a binomial cumulative distribution function. So, and it prompts you, it says, how many trials would you like? Well, it's 4 mornings, and there's a 1 in 3 chance the alarm works, and we want to know the probability that it works at least 3 times. So that's 3 times or 4 times, and we just go OK. And look at that, it loads it for us, and 0.111111 is indeed 1/9. Another way you could do it is just by typing it. So let's try typing it for works fewer than 2 times. So you type binom CDF. So the probability, the number of trials is 4, the probability success is 1/3, and we want to know from 0 to 1. 0.59259. Okay, let's see. 38 on 81. Okay, now it wants to give me an exact value. Oh, what's happened there? 4 1/3, 0, 1. Have I made a mistake here? Let's check. 2 to the power of 4 is 16. 4 choose 1 is 4. 48. Oh yeah, it's 48 on 81. I've made a mistake there. 48 on 81. There we are. That's our answer. 16 plus 32 is 48. Whoops. That's why we check with CAS. Very good to check with CAS. And of course, you won't make those mistakes on the exam. You'll be much more practiced with your mental arithmetic, and you'll check your answers over and over and over. So yeah, that's how we use the cumulative distribution function to calculate with CAS. In the next example, in the next video, we're going to have part 3, and we're going to look at how to use the probability density function. So it's kind of like a backwards thing, where we have the probability and we want to know how many trials. So we might work out, say you wanted to have an 80% chance of winning a Mars bar, how many Mars bars would you have to buy? We'll do that style of question. And if you have been, thanks for watching.